Okay, we are going to revise what we did in the lesson last week. So once again, we are still here on the topic of matrices. Still a bit more information to impart on this particular topic. Now, last week we talked about Barry and his two shops, his two shoe shops. He has got a load of stock, and first of all what we needed to do was write a matrix or create a matrix that included that stock. So if we've got 8, 9, 10, 11 and 12 sized shoes, and we have got Nike brand, Adidas brand, New Balance and Reebok. Our matrix, when we sort of nutted out the information that had been included there, was that we had 13 pairs of size 8, 13 of size 9, 13 of size 10 and 11 of each sizes 11 and 12. We had 10 of Adidas, 10, 10. We actually had just 10 of everyone here. We had in New Balance 15, 15, 11, 11, 11 and 9, 9, 16, 16 and 15. So when we actually create the matrix, what we do is we just get rid of all of this stuff on top and to the side here, and get rid of that and put this in this way. Okay, now the information also told us that this matrix was called T, and it also asked us to find T3, 4. Okay, so just revising what we have gone over in that regard is that this is our row and this is our column. So row 1, 2, 3 and column 1, 2, 3, 4. So 11. That is T3, 4 equals 11. Okay. Now the second thing we were asked to do was to share the stock evenly between Bordertown and Murray Bridge, and that required a little bit of complex manoeuvres because we couldn't split up these pairs of shoes obviously and have 6.5 pairs of shoes because they'd be of no point. So we needed to make a decision. If we were going to have Bordertown matrix over here, we could have that there were 6, 6, 6, 5, 5, then we could have 5, 5, 5, 5, 5, we could have 7, 7, 5, 5, 5, 4, 4, 8, 8 and what does that come to? 7. Okay, so that's our Bordertown matrix. Then we can have our Tailem Bend, no, Murray Bridge matrix. And so our Murray Bridge matrix is going to be 7, 7, 7, 6, 6, and 5, 5, 5, 5, 5. Then we're going to have 8, 8, 6, 6, 6, and 5, 5, 8, 8, and 8. That's right. Okay, now the point of this, the point that we need to be aware of here is that, let me just change this, that this matrix here added to this matrix here is equal to this matrix here. Okay, and as we know from any algebra, that means that T, just a moment, T equals B plus MB, right? And the important issues to consider here, which you guys all understood by the end of the lesson, was that T, B and MB, so all three matrices, need to be of the same order if they are to be added together. Okay, and that goes for subtraction as well. Now, if we continue on with the subtraction and addition of matrices, let's start with one that's perhaps a little bit smaller. If we have got a matrix A, and let's call it, we'll just go for 3, 2, 1. And if we have got a matrix B, and we'll call that 1, 2, 3, 4. If we want to find the sum of A and B, then what we do is we simply add together each of the corresponding elements within each of the matrices. Okay, so A plus B equals, we go 4 plus 1. We have 3 plus 2, 2 plus 3, and 1 plus 4. Okay, now you guys achieved this on your own without much help from me last week, so I don't think you have got any problem in understanding it. But the big issues, as I've already discussed, are that if you are going to add together two matrices, or if you are going to subtract one matrix from another, so if I'm going to do A minus B, I'm going to have 4 minus 1, which is 3. I'm going to have 3 minus 2, which is 1. I'm going to have 2 minus 3, which is minus 1. I'm going to have 1 minus 4, which is minus 3. The big issues here are that A, B, and let's call this one C, okay, which is equal to A plus B, are all of the same order. Okay, so that they're all 2 by 2 matrices. Okay, if we have got the A minus B is equal to D, then again that is a 2 by 2 matrix. Okay, all of the same order. So when you are talking about addition and subtraction, you need to be remembering that the matrices must be of the same order. Very important stuff. Okay, very good.